Oh, oh, we've been talking about this workshop, me and Alejandro, for some weeks, and we decided to do something that is towards job placement, right? So you need to get jobs, you need to go through coding interviews, and I know that sometimes it's not easy. Can you guys hear me? I think it was with background here. So it's not easy, right? So we try to find techniques and ways to solve things, but what are they really looking for, right, on a coding interview? So so you know, um, one coding challenge that is given to someone who has 1 year of experience, the same coding challenge that is given to someone who has 3 to 5 years of experience, or five plus year of experience. And then you tell me, but what's the difference then? So the difference is the expectation, right? How you solve it, how you get to your solution. And this is what I'm here to talk about. I would like to show you some ways to get results from the most problems that happens. And I've chosen some two topics to talk about, which is sorting. And this is a pretty common functionality that you need to implement in any application, and recursion. And I decided to talk about recursion because this is the topic that recruiters love most to interview. This shows your techniques and how deep you know any programming language, right? So recursion is it's a very good way of solving any given problem. However, most of the problems that you solve with recursion, you can also solve iteratively with loops. However, this can get very complex with loops. And you will see we are going to solve 4 different exercises here, and all of those are going to use recursion. So I decided to talk about merge sort, which is one very common sorting algorithm, and binary search, which is doing a search through a ordered array, right? And through a sorted array. And then we're going to talk about recursion. But before starting this, before starting a merge sort, how many of you is familiar with recursion? Or better, how many of you guys are not familiar with recursion?
Yeah, I never heard of it before. I just was gonna ask you what that means, but you answered it as soon as I was gonna ask you that.
Yeah, so we're going to talk about this now. I'm going to give an introduction to recursion. Then we can start talking about sorting, because in all these exercises, we are going to use recursion. So recursion, it's it's a function that calls itself in order to get any given result, right? So let me. So here we do have, imagining here a factorial of n, and n is a parameter that can be any number, right? Let's let's call n 4. Factorial of 4, it is equal 4 times 3 times 2 times 1, and this is equal 24. So we can do this through a loop, but doing recursively, we would have factorial of n, or let's have here 4, it's equal 4 times factorial of 3, right? Because if factorial of 4, if 4 times 3, and then factorial of 3 is equal factorial of 2, of 3 times the factorial of 2, and factorial of 1. So a way of solving this with factorial, it would look something like that. So imagine here factorial function factorial, and we're going to receive a parameter here, and the only thing here is we need to have a base case to get out of this loop, right? Because we cannot be calling the function itself, otherwise we're going to get an error. And this error is our stack. It will be full, and then we cannot call functions anymore. So the base case, like I was saying here, we have...
Sorry, João, sorry. I don't know if it's only for me, but I don't see all your screen. I see only a part of it.
Yeah,
Which part?
I'm the same way too.
Ah, okay. So it's cut, so we can see the left side and the right side of your... Oh, okay, now you are make it bigger. So I said
Can
for
you
the
see
guys.
now or not? Or not
No,
yet?
the left side is still, we see only the n inside the parentheses and the curly brackets. At least what I see.
Just
Okay, now I
but no.
guess everybody, just the FU in the function is not visible.
Okay,
I don't know why, but is.
Can you see now or not?
I don't, but I don't know you guys if you can see
One
correctly.
second. 1 second. Can you see now?
No.
It's still showing like the same way like that. The end on the function part, the only thing we see is the end part on back.
Exactly.
Okay, 1 second. Let me stop sharing and share again.
Yeah, probably.
What now?
No, it's still,
Still the same.
yeah, actually it came back like it was before.
Now, 1 second, because I will need to disconnect this.
Lexi, you're not sharing the whole part of your screen.
Oh, I know what's going on. Now can you see?
Now it's perfect. At least for me.
Okay. So for factorial, we need to have a base case, because if factorial of 4 is equal 4 times 3 times 2 times 1, and we know that factorial of 1 is equal 1, right? So on this base case, we'll have if n is equal 1, return 1. And this, what's going to happen is all the stack, when it gets to 1 is going to tell 2, hey, my value here, factorial of 1 is equal 1. And then this 2 it will multiply 2 with 1, and we'll have the value of 2. Then 3 will multiply 3 with 2, would have value of 6. And 4 would multiply with 6 and would have the value of 24. So, but to do that, in this if condition, we return 1, else, or we just place return and multiply by factorial of n minus 1. This n minus 1 here, if we call this factorial with number 4, it will be 3, right? So we will be doing 4 multiplied by 3, and we are going to be calling this function again. So when we call, this n will be 3, and it's not equal to 1, so it's not going to return 1. But then we will have 3 calling 3 minus 1, which will be 2, right? And 2 here, we'll call 2 multiplied by 2 minus 1, which is 1. And then when we call again here, returns 1. And this 1, it will return back on the stack, doing all this multiplication back. because a function cannot return if it's still calling another function. But then when the stack is complete, we would have 24, then the return will be 24. Well, let's test that. If we call factorial of 4, and we run that, then we have 24. So what we can do also here, we can do a console.log, and here. So we see all the numbers that is being going down here because of this operation. And we can also see console.log, in console.log this statement here. Let me just comment this one.
Hey, so basically what you saying, that factorial is equal to 1?
Factorial of 1 is equal to 1. So factorial of 4 is equal 4 times 3 times 2 times 1.
Okay.
Right? So factorial of 1 is equal 1. So if we know that factorial of 1 is equal 1, we know how much factorial of 2 is, because factorial of 2, it is, imagine here, 2, and then we'll have 2 minus 1. And factorial of 1 is 1, and then this result here, which this is 1, it will be 2 plus 1. So factorial of 2 is equal to 2. So when we have here factorial of 3, we would have 3 minus 1, and this is equal to 2, right? So factorial of 3 is equal 3 plus 3 times 2, which is 6. And for 4 will be factorial of 4 times 4 minus 1, which is 4 times 3. And the result of that multiplication, 1, 2, and 6, it will be 6 times 4, which is 24. That's why we have these values here, 2, 6, 2, 24. And that's how we get to 24. So on the simplest way of saying that recursion is a function that calls the same function, but we need to pass something else to change this value here, because the same value will be an infinite loop, and we need to have a base case, right? So when we get to a certain number here, we return 1. It's like a for loop. We have I equals 0, and while I is less than r dot length, or there is a base case. We need to have an exit, right? Because this exit, it will give you, it will like not let you have an infinite loop. Are there any questions on this?
So right there where you see where you put console.log factorial at? So
Yes.
what if you would have put 8 right there? No, where the second console.log. So what if
If I
you would
put,
have what if
if
you
I
would
put
have put 8
factor,
right there? Like what if so it would have been 8 times 8. I mean 8 times.
no. So then if you want to say the factorial of 8 is not putting it here like that, we can call this number. So here, instead of 4, we can pass 8 here. So then we can, what is this? Oh, yeah, so all this is not gonna let us run anything. So when we call factorial of 8, what is,
It looked like that second part where you got that factorial where the n minus 1.
what is it? Yeah, my JS beans just been giving. Okay, so now we have factorial. Yeah, it's like when I hit run, it's like I hadn't comment those lines. So factorial of 8 is 40,320. So now you have a a function that determines factorial of any number. And factorial of 20 is, and this number here is factorial of 8. It is 8 times 7 times 6 times 5 all the way to 1. And then we're going to do 1 plus 2, 1 plus 3. All the results is going accumulating, and we get, when it gets to 8, we get this result here, 320. All right?
Yeah.
Okay, so with that in mind, we are going to do merge sort here. So with merge sort is, we have an array that has, let's start with 8 numbers. So we have 4, we have 7, we have 3, we have 5, we have 1, 2, we have 6, and we have 8. Okay, so the way of sorting this, okay, for an interview, for a day-to-day job, we can do console.log r.sort, and this will sort the array for you, right? So you will get the result here. But for an interview, if you are asked to do sorting, how would you sort this array? So one common way of doing this is bubble sort, right? Bubble sort, you need to do a nested loop that compare this number with this number, and this number with this number, and then pass 3 here, and 7 goes there, and you keep looping that. But that, you're going to have a nested loop, which, depending on the size of the array, and I think I have a sorting. So here we have all those algorithms do a sorting, right? So once you do bubble sort, which you have here, this is how it sorts your array, right? So you keep doing all these operations in order to sort this array. So let's random this again and look. It is, and this is merge sort, what we're going to do here. It's already done, look. And merge sort still doing. Let's run them again. And this is merge sort. And bubble sort still doing their job, right? So there are better algorithms than merge sort, but actually they have the same time complexity. I'm not going to get into time complexity today, but merge sort, heap sort, and quick sort, they all have log n for time complexity. So on an interview, if you are asked to sort an array, and maybe the base case, the example would be 8 items, but then they're going to use test cases with an array with 100 items, 1,000 items, 1,000, 10,000, and so on and so forth. So bubble sort is not a very good algorithm to do this, right? So when we random, let's do reversed here. Bubble sort, it takes whatever. So this is what the computer is doing behind the scenes. It's doing all those functionalities running and takes time to solve. That's why I chose to do merge sort here, because we start with some recursion too. That's why I explained initially how we work with recursion. So let's declare one array here, merge sort. And we are going to receive an array. Okay, let me try, before I want to show you this. So Paulo,
Yeah?
Let me know if you can see part of the screen again.
No, for me it's fine.
It's fine, but I'm gonna connect my iPad on it. That's why. Because I want to draw to explain this. Can you see the entire screen?
Nope.
Where,
I don't
where
see
does
the
it go?
left part of your screen.
The left part. Can you see my mouse here?
Yep.
Yeah, the mouse. Yeah.
Where does it end? Here, still can see.
You are below the tree in the array. I see merger, sort. I don't see anything on the left of merger, sort.
Okay, so just this part after on the
Okay,
left
now
side,
it's fine.
you
Yeah,
can see
now it's
it.
fine. Now it's fine.
Okay, can you see everything?
I think yes.
Okay, so, cool. So, yeah, I want to. Okay, look at this. Merge sort is an algorithm that it split your array in half. So once we have here an array, let me just stop selecting this. Over there. An array with 4, 7, 3, 5, 1, 2, 6, and 8. What merge sort does is it splits your array in half, so you will have 4, 7, 3, and 5. And on the other half, you have the other numbers 1, 2, 6, and 8. And because it's recursive, it will keep calling the same function again. So if the function, what's the base case of that? The base case is an array that has length of 1, right? So if it's 1, you cannot break the array anymore. So we're going to have here 4 and 7, and we're going to have here 3 and 5, 1 and 2, 6 and 8. And you can do it one more. 4, 7, 3, and 5. So this is the base case, the length of 1, right? So on the other side, we'll have 1, we have 2, we have 6, and we have 8. So if we cannot split anymore, we need to start putting it together, right? So that's what merge sort does. It breaks the array to the minimum possible, and then start putting it back together. Let's just do a different color here. Okay, so to do that, they use comparison, and they're going to compare 4 with 7. So 4 is less. Which one is less? You would have 4 and 7. Here, 3 and 5, they're going to also compare those two numbers, and it's going to put 3 and 5. Those two, they were already sorted. But now it comes, you need to put it back with 4 items here, right? So you're going to compare this number with this number. Which one is smaller? 3. Then we add 3 here. And then we have 4. We add 4 here. Then we have 7 and 5. Because we incremented the count, we pass to the next one. So the smaller is 5. We pass 5. And then we pass 7. And the same thing we're going to do to the other side. Here we have an array with 2, like we have here. And they were already sorted. So this is an easy thing, 1 and 2. And here 6 and 8 was also already sorted. So you don't need to compare because you know that it's going to be 6 and 2. But now you need to come back here for an array with 4 numbers. And here you're going to compare 1 with 6, and 1 is smaller. So we do 1, we increment the count. We come here, we compare 2 with 6. 2 is smaller, so goes 2. And then this is already sorted, so you can automatically send 6 and 8. We got to the end here, and then we didn't choose any of those. But this we sorted here, right? It was already sorted, but if it was 8 and 6 here, we would sort and put there the sorting one. So here for the final one, we're going to do the same process. And I'm going to tell you. So you probably during the course, you've heard divide and conquer, right? And this is a design strategy actually, that you divide your input and you start putting the solution together. You solve smaller portions of the entire solution, the entire problem, because this is a smaller portion of this entire problem here. This is also a smaller portion of this problem. So you go to the smallest possible and you start putting back together piece by piece. So here we're gonna do 3 with 1. The smaller is 1, so we bring 1 here. And then 3 with 2. 2 is smaller, so we bring 2. And we increment the count. So now 3 and 6. 3 is smaller. Then we increment count here. We will have 4 and 6, with 4 is smaller, so we bring 4. We increment the count here to 5, and we'll have 5 and 6. 5 is smaller, we take 5. Then we have increment the count, 7 and 6, we bring 6. Then we bring 7, and then only one that is missing. So this is how merge sort works. Rather than be comparing those two numbers and swapping, right? Because this is what bubble sort does. It swap the numbers. But now, with this approach, you will have much faster solution. Your algorithm is going to run way faster. So, questions on this? Okay.
Yeah,
so
I got a quick question. So
go ahead.
you see up there where you got the array and you got the numbers 4,
Here
7,
or here?
3. Nah, where you wrote the
4,
array.
7, and 3. Yes.
And then you got const, merge, sort, and then you got equals array. So when you do that, would you call array like that, or would you just write array in how you wrote it?
This here is just a parameter. We can pass any name here. So when we call the function, we're going to pass this number here, this variable definition, which will represent this entire array that will be coming here as a parameter. So what I'm calling here, it doesn't matter because just the parameter, but I need to use that same name inside the function.
Okay.
Okay. So let's code this. Okay. So we know that our dot sort works. So merge sort. What do we need to do first? Look back here. What do we need to do first?
Copy the array.
What was that?
Copy the array, create a new array, or just like list array.
How do we can copy there, but you're gonna copy for what purpose?
So you can start like doing the sort or splitting it out.
Okay, so you need to break it. How do we break an array in half or any inquiries?
Divide by 2.
We divide by 2. This is we can divide by 2, I guess. I would say we need to have how do we define the middle point on the array? It doesn't matter if it's even or odd number here. How do we get the closest?
And take the length and divide it? Or?
take the length and divider. So we can say that mid is equal array.length divided by 2, right?
It will work if it's an even number, right?
Yes, but it doesn't matter if it's not. So let's put the console log here, console log, and we call merge sort so we can do debugging. Okay.
João, the left side is still a little frozen because I just see the.
So let me do this. What now?
Yeah.
Okay.
Yes, much better.
Okay, so let's have it this here. So we can call and then we can console log to see what we have with mid, right? Oh, but now I cannot. Let me 1 second. Okay, can you see still the array declaration?
I can see the edge, I think, yeah. Well, at least I can see it.
Okay, so when we run, merge sort's not defined. Merge, I have a typo here. So now we have 4. First, is half of 8, which is the length, right? So we can use mid, so we know that mid is half. And even if we add one more number here, 4.5, how do we solve this? This problem here.
You can use math.floor.
Perfect. Math floor. And now we are going to have 4. And it will work the same. So we have a midpoint here. How we declare now a left side of this array? I want to have this. And I don't want to create like a copy of the array. We don't need to create a copy. That's the thing. We don't need to use memory to create a copy because
it's like a method, like a substring method.
We can use a method. Which method would be the one? So the method that we're going to use is split or slice. That will be slice. So slice, we are going to do from 0 to mid, okay? Because it will start from here, and we will go to the value of this variable, which is 4. So this is 4. So we're going to get this side of the array. And then from the right side, we're going to do array dot slice mid. Because we are going to start from mid, which is 4, and we know that we start from 0, and so this is 4, right? Once we use mid here, we actually go up to, but we don't count mid. So this will give us 2 arrays, and let's test it. Log left and console.log right. Okay. So we run, we do have 4, 7, 3, 5, 1, 2, 6, 8, 9. All right? So now we are going to use that recursion to solve this. But there's something that I'm forgetting here. So what's my base case here? What's the case that if it's that result, we just return? Can I sort an array with 4 elements?
That's not.
Right?
No.
It's 4. I can sort an array with 4, 7, 3, and 5. It would be 3, 4, 5, 7, right?
Right.
Can I sort an array with 3 numbers? 3, 4, 7, and 3.
You should.
Yeah, it was going to be 3, 4, 7. And what 2 numbers? Yes. I still can, and it's already sorted, 4, 7. But what about 1 number? Do I sort an array with 1 number?
No.
Because I'm going to compare with what, right? So that's the base case. We're going to do if array.length is less or equal 1, we return, what do we return?
The number?
Which number?
That number you're evaluating.
We need to return the array sorted, right? That's the proposal of merge sort. We need to return this array with 1, 2, 3, 4, 5, 6, 7, 8, 9. But if there is one number, what do I need to return? I return the array because it will be sorted already with one number. And that's it. That's sorted. That's your first return. Because one element on the array, you do not sort that. It's already sorted for you. You return 4. All right?
Okay.
Okay, that's cool. Now, we need to recursively call merge sort while the condition is not met, right? But here's the deal. I'm going to tell you that there's a very interesting way to solve recursive problems. And now that's the point that I want you to really pay attention on this recursion thing. Even though this is a sorting algorithm, we are going to use recursion. And I will say return, and I'm going to call this helper. Helper is going to be a helper function. Hey guys, if you are not talking, can you go on mute, please? Oh. I will call helper is going to be a helper function. And this helper function, 1 second.
Herman, you're on mute. You're unmuted.
Yeah. Okay, now we're good. So this helper function we'll call, we have two sides. We have left and we have right? So we need to call merge sort for that left side. Remember, we have this left side here. And this left side, it needs to be broken down, right? So we're going to call merge sort on the left side. And we're going to call merge sort on the right side. Cool. What now? What do I need to do now? What is this? What is this?
That's
like a helper function?
Function, right?
I need to declare this, otherwise I'm going to get an error, right? So let's declare a function that's called helper. And we're going to have two parameters, one left and one right. And I'm passing merge sort function here when I call. So we're going to get to that. Okay, so on this function, what I'm going to be doing is comparing the numbers and putting it back together. Because when I call merge sort left on the helper, I'm sending this array. And then I'm call again and keep breaking, right? Till get to this size here. When it gets to this size, then this helper function needs to act. You need to start putting it back together. So what do we do here? We will have two arrays, right? Because this left and right, these are one array and this is another array, okay? So if we have two arrays, we need to have a pointer for left. I'm going to call L equals 0. I'm going to have let R equal 0. And that's cool. But now, look at this. If we have left side and we have left side and we have the right side, and we compare both, and what do? We start filling up an array, right? This array here was empty. So I compare 4 with 7. Okay, 4 is less. I send 4 to the array, and then I send 7 to the other array. Then I will compare this array with this array. I will compare 4 with 3. 3 is less, then I put 3 there. So this is what we need to do to get this result that will give us this result, right? Okay, so what do I need here now? I have the pointers that will be showing in which number it is, but when we find the number, what do we do? Where do we send? We need to have an auxiliary array to have this result. So we have auxiliary, that is an empty array. And here we are going to start implementing or sending those numbers 4, 7. So they are now on this auxiliary array, right? So then we are going to compare those numbers and we are going to send to the auxiliary array. Okay, so we have this. We need a loop to go through this. And that's not a for loop that I'm going to use here. I'm going to use this, and I'm going to say while L is less than left.length and R is, less than right.length. What do we need to do here? Now, how do we compare elements that's coming from this?
Hey, Enrique, I'm eating. I had to cut my camera off.
I ask, how do we compare elements in two arrays? Two different arrays. Imagine that we have two arrays here. How do you compare this element with this element?
You do two actually doing like a by index.
Well, we are not using index. We are using R and L. Those are our, like in a for loop, we have let I equal 0 and over. So here I'm declaring two indexes, which is L and R, right? L for tracking the array left and R for tracking the array right. Because here we have left, this is an array, and this right is an array. We have C right here, right? I have those two arrays. So we're going to do if left L, which is the first element then, is less than right R, which is the first element on this array. So if it's less, and we need something to be less, right, to start sorting. So where do I send this? Where do I send this number here?
To the auxiliary.
To the auxiliary. So aux.push left L. Else, if this condition is not true, who needs to go to the auxiliary array?
The right one.
Right R. So we can say else aux.push right R. Is this good?
Okay.
Yeah, it looks like, right?
You have to return the auxiliary array.
Great. We need to return aux. Is this good now?
Still no.
Still no. What do we need to do? And I can tell you, I can run this. It's going to give an error. Or not even run. Well, we will have a stack problem.
Because we don't have a counter. I mean, it's going to stay infinitive. Wait a minute.
1 second. Yeah, you were right. You were right. I need to refresh this page because...
Yeah, it's kind of like...
So, look the result. You saw it, right? On the console.
Yeah.
Really bad. Okay, so we need to increment counter. We need to increment L. Ouch. Again, 1 second. I don't know why I pressed run. Okay. I guess now we're good. Let me save this. So now we increment L because we need to move on, right? To the next. Once we send, we need to move on to the next element and R++. And seeing here, once we send, look, if we are here and we send 3, right? And then we need to move the 3, which is L from left, we need to move to 4, right? And then when you send 1 or 6, we need to move to the last element. We need to move and then keep sending those elements. That's why we need to increment count. So is this good now?
Yeah.
This is still not good. That's because here in while, this is a Boolean expression, right? And we have E here. So what happened once we finish the left side? This is no longer true. And then we get out of the loop, right? Or if we get to the right side, to the end of the right side first, this is going to be false. And then this entire expression is false, and we get out of the loop. And we do not finish sending those other elements. What do we do then? How do we fix that?
So you want to check if you reach the end of the length of each one of the arrays?
We have a better solution. We do concat here. aux concat left dot slice L dot concat right dot slice R. Then you tell me, what is this? It was going good till now. What is this? So this is saying, let's say that we have here aux equal, and then we have 1, 2, 2, 3, and we have on the right side, we have still on the other array, because we sent from left and right here, right? But on the right side, we still have 4 and 5. Okay, so this array is we send it here, we sort it and we send it to aux. If we finish, if we finish here 6, 8, 6, 8, they are sorted already, right? We send 1 and 2, and this we got to the end. Using 1 and 2 as an example, the left side it's done, so this became false, but we still have 6 and 2. What do? We concatenate the right side. We'd have 6 and 8. So we don't need to do any operation because we know that it's already sorted, right? We already sorted. We are just putting it back. So if we get to the end of any side, it means that the other side, it is already sorted. Just concatenate and return it, right? That's what it's doing here. But why did I put 2 arrays here? Because if the left side is done, it will be empty, and the right side send the right side. But if the right side is done, the right side will be already in aux, so I can pretty much send the left side to it. Okay? So now we can run this, and we have the sorted array.
Nice.
So let's see what happens if we remove this. Have 1. Because, and why is that? Because here I will compare the first number, right? And the first number, return aux. Then I will get here, if the array.length is less or equal 1, return array. That's what I'm doing right here. I return the array with length of 1. So we need to have this. Okay? Guys, I need to move to binary search because I have other 4, and I have a repository here. I will send you can check it out. We have merge sort.
Nice.
And I will commit and I will send you this code. Okay, so I just need to move, otherwise we are not going to see all the exercises. Okay, so binary search. binary search, it works pretty much like merge sort. The difference is that the array is already sorted, right? The array here is 1, 2, 3, 4, 5, 6. I'm gonna use a small array just for the sake of time. So let's add 7. So we are gonna have a midpoint as well. We're gonna use that same code. We're gonna get the middle point, which will be 4, right? So to search something, you will have the array and the key, what you are looking for. So let's say we're looking for 7. So you're gonna have your midpoint, mid is equal 4, and then you are gonna compare is 4 less or bigger than 7? Well, it's less. Then I don't need this array. Now I have 5, 6, 7. You're gonna recursively call the midpoint again, which will be 6. Is the midpoint equal the key, which now mid is 6? No, it's not equal. It's bigger or less. Well, it's the number is higher. Then we just slice that part. Now we have 7. Is mid? There's just one array, so mid will be equal 7. And then we compare. Is mid equal the key? Yes. Return. Return. Well, you can return array mid. And that's going to give you the key. If you get to this number 1 and it's not the key, you return not found. Item not found. And let's code this and it will become a little more clear. So I'm going to create a function here just to generate number, generate R. Here we're going to have num, and we're going to have let aux equal, and then we loop for let I equal 0, I less than nums, that's our equal, nums, num, I plus plus. Okay. Oops. Okay, so now I just need to do aux dot push I and return I. Return aux. Return. So this is going to be an array with the number of items that we want. Okay, so if we console log this, console.log, generate R, and we pass 1,000 or 100, let's do 100, and we run, we have an array with 100 numbers. Okay? So I did this just to have the array here, and we can use it to do our binary search. Okay, so now we declare const binary search, and here we're going to pass as a one array that we're going to look through and a key. So we need to, the first thing we need to do?
We need to split the array in half.
Well, we are going to do that. But not now, not yet. The first thing we need to do is we need to define mid, right? Which will be array.length divided by 2. And here we need to do also the math floor. Math.floor. Awesome. So now let's do our console log here to make sure that we are doing this binary search. Oops, that's not right. Search. And we pass generate. Oh, well, I can store this in a variable. Const num equal. Now it pass. No. So okay, so now we can do our console log mid, and we clear this, and mid is 50, and it is right? Because if it is 100, 50 is half, which is cool. Okay, so mid is working, everything is working. So we have mid there. What's our base case here?
Oh, come again?
What's the base case? The base case, in a recursion, we need a base case to get out of the recursive call, right? In the base case here, it will be if key is less than array 0, because this is ordered and it's number, right? Or key is bigger than array dot length, not the this array dot
When you
length.
say base case, you mean like the default or like the one that just like goes in the edge cases?
The base case that take us out of the loop.
Oh, okay.
Look here.
Okay,
Here we have a base case.
I got you.
If array dot length is less or equal 1, return array.
Okay,
We need to have a base case, right?
I got it. Thanks.
Like on the factorial, if n is equal 1, return 1, right? That's
Right.
the base case for a.
For factorial math.
And here we can say if key is less than array, less than the first element of the array, or higher than the last element of the array, by. It's not there. So then we return not found. And then what? Then if key is equal mid, not even mid, it's R mid. Oh, array mid. What do we do then?
If that is equal, we found the number that we need. Just have to return the number.
Exactly. We return array mid. We will return the number. That's exactly what we do. That's the end of it, right? So if we find by, we found it. What if we don't find? Should we call helper, or we can do an else? I think we can do an else here. Else, but on this else, we will have two options. Two options, because, okay, this is not very good. Two options because if the key is on the left side of the array, I need to slice left. But if it's on the right side of the array, I need to slice right and call the function again. So if I need to call the function again, I'm going to say if key is less than array mid, then I'm going to call binary search. And what am I going to pass here?
Well, you gotta pass array mid.
We know that these are we are passing two parameters here, right?
Right.
I mean, this is arguments. We're passing two arguments here. And these arguments are going to be array dot slice. And if this is the left side, it's going to be 0 to mid, right? And we are going to pass the key. Else, what do we do on else?
We pass the right side, which is binary search array slice mid and the key.
Yes, perfect. Get rid of the 0 here. Is this correct?
Yeah. That's nice. We have the floor. Yeah, okay.
Let's get a random number. Math, floor, math, math, random, multiplied by num. Not num. 100. So we can get a random number in this range, which is the same range as here. And we console log, we pass num, and we pass rand num. Okay. So I'm gonna actually console log here so we can see that random number, which one it is. I'm gonna put a marker here. Have this here. Let's see if we have any console. Okay. Oh, I'm gonna also do this console.log array. So you were gonna see what happened with the array once we call this function. We run. Okay, so the random number is 37. Okay? So we start the function. The first time is the entire function, 0 to 100. So 37 is on the left side. So we get the left side of the array. Oh, we're not returning. We are returning. What's going on here? Binary search, mid key.
Oh, you did the if key, and then you didn't put a return on the binary right there? After the else?
I don't need to put a return because our return is here.
You're calling back the function. Okay, never mind.
Yeah. Whoa, let me do this because my JS bin. So let me see if I here and run 64 undefined binary search key. And key is bigger than array dot length -1, number not found. Key equal array mid. If L. What am I missing here? What are we missing here? If
Is it the random number? Well, yeah, it's 64 because never mind that.
yeah, we need to know the
From 0
is right there. Let me do this. Let me do this with the helper. Let's return helper. Else. Oops. Return helper. Let me pass head.key. Array. Function helper array key. I think cannot believe there was this. Okay, let's try it. Undefined still. Made a thing. Okay, so I'm not gonna be wasting our time here. I'm gonna put this here so we can find this error. was different.
Go back again, back and forth.
1 second. Mat floor. If this, I don't know why is this not working. It wasn't working actually. Armid key, Armid. Can I pass? Well, either way, I'm gonna put this here.
Same code, right?
Yeah, huh?
Same code.
Yeah, same code. Yeah, I was solving this before class today.
Yeah, no, I know, but I can see that there is no difference on the.
Yeah, it's
All right.
okay. So we have here if, and we have else, and we have the helper here. So once we generate that, we have 77 console
Okay.
log here number, and now let's console log this array.
Yeah, I was going to tell you that to put it closer so I can see the arrays how it goes like lower and lower and lower, including left and right.
Okay, so we have 75, and we have this array here, which is 75 is bigger than 50, so we have 50, and is surprisingly 75 is the middle point right here. So then the function ends, and that's it.
Run on one more time, please. Thanks.
Of course. Now we have 83. Oh, that's cool. When I wrote this function earlier, I got 83 too. So 83, we have the first function. Then we split the function. And 83, the middle point here, it's over 75, but less than 87. Look, so we have this part. So in 83, we slice again, 81, 82, 83. Then we slice again, 82, 83. So the next one is 83. So we return that function.
Nice.
So this is binary search. But the thing is, to use binary search, it needs to be sorted. The array needs to be sorted. All right. So
it has to be in order first before you can actually use the binary search, right?
Yes. So on an interview, and this is something that you need to really pay attention. On an interview, they're going to give you something, and there will be hints. There will be, if it's to work with an array, it will say, oh, do this on a non-decreasing array, which is a non-decreasing array is a sorted array, is an increasing array, right? Or on a decreasing array, which means that is from higher to
from higher to lower and so on.
Yes, exactly. So I'm going to copy this.
Nice.
But here on binary search. And do you guys have questions on this binary search?
No, but later we look at the code little by little so we can absorb it.
Okay. So I'm going to move on because we are past half time already and we have other two, which is this is the piece of cake. Okay, so we have here, this is a LeetCode platform. And if you are not familiar, LeetCode has a bunch of problems that is used on FANG companies, like FANG is Facebook, Apple, Amazon, Netflix, and Google. Plus all the other companies, they follow whatever those companies do. So in order to practice for these interviews, not just this, any interview, you need to have the basics of algorithms and data structure, right? So usually they use a medium level problem to anybody that's going to go through a coding interview. So this platform is awesome. But I also recommend, depending how you are with algorithms, 4Geeks has a repository that has 160 JavaScript problems. I did, when I finished the program, I completed that 3 times from the beginning to the end. And then I started get good in JavaScript. So the first thing to do is get very comfortable with the programming language. So you do not have syntax errors, right? has less syntax error, it means that you have more intimacy with the language. And well, anyway, so letter case permutation, and this is purely recursive, right? You can use iteratively, but then again, what's the best way of solving this? So on this problem, it says, given a string S, we can transform every letter individually to be lowercase or uppercase to create another string. Return a list of all possible strings we could create. You can return the output in any order. So if we have A1, B2, so now let's, can you guys see the entire screen?
Yeah, I mean, for the most of it, it's just a little bit wiggle on the bottom. I'm not sure if your iPad is actually rendering.
It's because on the bottom I have this. Oh, okay.
I got it.
Okay, so I'm gonna put back here, and I'm gonna clean this screen because we can use this. Let me see, I already put here, right? Okay, binary search is here. Then we can use this white space here. Okay, so look at this. We have that string, which they have A1, B2. And we need to return A1, all this here. I'm gonna copy this. Okay, we need to return this, right? And they are giving us the first one. They are giving us A1, B2. Okay, so this is where it comes that design strategy. We were talking about divide and conquer, right? So, but divide and conquer would mean that we need to get something and split in half, and then this half we need to split, and this split we need to split, and this is divide and conquer. This is what it means, divide and conquer, right? But for this kind of problem here, there's another design strategy that is called decrease and conquer. I don't know if anybody of you already heard that, but this is actually a design strategy that is used to solve algorithms. And there are four. So just so you know, that is brute force is what we do when we are just out of boot camp. We use brute force. We want to solve no matter what. It doesn't matter if it's good or bad. We just want to solve because that's what we want to do, right? So then there's divide and conquer that we just covered with binary search and merge sort. And now we're going to talk about decrease and conquer. And the fourth design strategy is called transform and conquer. But we're not going to talk about this today. Okay, so if we have this and we use a decrease and conquer, it means let's solve this part first. So if we want to solve this, we can say that this can have two solutions, right? And the first solution is A, and the second solution is this A, because we have this here, and this is the same, so we don't need to do anything, and we have this that is different. All right? Okay, we decreased this. So what's the next? The next is 1. Oh, let me clean this because I'm doing this mess here. Not nice. Okay, A1, B2. So on the left side, let's say that on the left side, we lowercase. And on the right side, we use uppercase. Okay? So if we are going to use this strategy of decrease and conquer, we are going to have on the right side, we're going to have lowercase a, and on the right side, uppercase A. Perfect. So we can say that this is my iteration 0. Cool. So for the second, which is 1, how many different sizes can 1 be? And remember that this is my output, right? This is what I have to have as a result, a return. And this is what is given to me. This here is the number that is given to me. And I need to return this.
You're talking about like how many different permutations, but really
Yes. How
like
many different permutations that we could, yeah, look, A1, B2, and so here on
right.
the left side,
No,
you
but
can see
on the answer we have 4 permutations. That's because like every upper and lower case have to be changed upper and lower, but the number's still the same.
exact. So the number is still the same. That's exactly it. So here there is nothing. We just add no operation. We just add 1 here. Good. So now we have B. So we know to the left side, B is lowercase, right?
Right?
So we do go to the left side. We pass what we already had, 1, and B is lowercase. And then
Okay.
to the left side, again, A1 and B is lowercase. Cool. So to the right side, B is uppercase, right? So A1, B. And to the right side, oh, the right side, oh, this is wrong. This here is, this A was already here.
Right, because it's uppercase, right?
Yes, because we're adding B, not A.
Now we're adding B to the right. Okay. So now it's like A1 and uppercase B.
Yes. So A1, uppercase B. And now we have it. Good. So we need to add 2. No changes on it. A1, B2. A1, B2. A1, B2, and here, here, and here. A1, B2.
So that's how you come out with the last 4 permutations, and that's your answer. Now with this,
That's my answer. That's my answer right here. Right? How do we code that?
Right.
So so we are also talking a little bit of trees here, right? So how do we code this? We know what we need to do. So if we know that this is not 0, this is 1, and this is 0, this is 2, the second iteration, and this is 3. So let's say that this is index 0, index 1, index 2, and index 3. Okay? All right.
Yep.
So let's go back to the problem. So if we follow this, we need to have, you see here, we have already an array. So we need to return an array with elements, right? So we come here. Let's have let result equal an empty array. Then I already will call my helper, and then I will pass the string. I will pass 0. I will pass an empty string, and I will pass result here, and I will return result. Okay. So now let's declare our helper function. So S will be the string coming. 0 will be the index. This will be the partial solution. Oh, let's just call partial just to make our life easier. And we're gonna pass result. What's the base case here?
Well, there is only one. If it's always gonna be, no, actually it can be only.
Let's come back here.
Only one, the first one, A1, B.
All the cases has the same length, right?
Okay.
This length is 3, and look our index.
3.
Our index is also 3. So our base case, it can be if partial dot length is equal index, then we return result dot push partial. And that's okay, right? Because once we get the partial dot length is 3 and is equal index 3, we push this to result, which is this array here, and we return the array. We are returning this array already.
Okay, the partial length is 3, but technically it has 4 elements. And you're doing
yes, because string is
because it's from 0, 1, 2, 3. That's fine. Okay.
Yes.
All right. Go ahead. So that will be your base case where you got to return the answer, and that's it.
Yes.
Okay.
In fact, call me crazy, but look at this. I say that this is 0, right?
Mm-hmm.
But this is not. This is in fact, this is 0, and this is 1, and this is 2. And then you tell me, how? Well, I just realized that that's because when it comes here, okay, so let's keep doing. Let's keep doing here this. We're gonna do if, okay, so we need to check if it's a number, right? How do we check? I'm gonna keep this here, this index.
Right.
Don't worry, I will not forget. We're gonna go back talk about it in a bit. So how do we check if it's a number?
You got it to the type of. If it's a string number, right?
But this is a string. This is a string.
Okay, so you got to check if it's a number on a string, inside the string.
How do I do that?
If the first character is a number, or any character.
If the current character, right?
Right.
Okay, so we are gonna check like this. You can check with, there's a function called is none. And this is not a number.
Right.
But we don't want to check that. We don't check, like, if it's not a number. It means that this is a number. And we pass, how do we pass the specific string index? That's exactly what I say, right? str index.
Yes.
Okay, so if this is a number, we're gonna call helper. We're gonna say, we're gonna pass string. We're gonna pass index plus 1. And we're gonna pass partial plus string index, comma result. We are just concatenating the number with whatever is there, or if it starts with a number, we're just concatenating with an empty string that we are passing here. This is the initial value of that function that we are calling, okay? So the initial value is the s, the string, which will be this that we're passing.
Right.
The index is 0. The partial solution will be an empty array, and result will be an empty array as well. Oh, this is an empty string. Okay, right. So what we are doing is we pass the same string, we increment the index, we pass partial, which is an empty string, but then we are going to concatenate with the first string or whatever index it is that we are at right now. So if it's index 0, it's A, we are concatenating A. If it's index 1, we are concatenating 1, go figure, and so on and so forth. Okay, but if this is not a number, right? I mean, if this is a number, if it's not, else, now we are going to call helper again. And here, let's put here lowercase. How do we make this string be lowercase? And I'm going to actually add here uppercase. How do we do this one, this lower and this uppercase?
There is a method for that, no?
Yes.
Who uppercase, who lower?
And the method is this. I'm not gonna let you just thinking about it. Lower is to lowercase. This is the method. Okay, this is the method. Where do I add this method?
You're gonna put it on the partial.
Partial is an empty string or whatever is already there.
Okay. Well, on the string.
Where?
On the string?
Yes. This string is the entire string. We need to put on the string index. It's right here because this is what we want to concatenate and pass it with the given value, right? So we're gonna do 2 lower case, and here will be 2 uppercase. Oops. Okay. Is this correct? Okay, going back to that index. Okay, when we come here, the index is 0, right? Index 0. Here, A. And then, okay, let's do this. Index 0, and we add 1. So now is the index 1, and we come here. Index 1, and we add 1. Index 2 is right here. So we add 1, index 3, and we are right here. But then we are going to get here. The index is going to be 3, but it's not going to get here. Okay?
Okay.
It's not going to get to 4. That's why we get to index 3. That's what I was saying before. That starts there. It starts on 0 and then 1, 2, and 3. 0, 0, 1, 2. Because it updates to 3, it goes to 3, and then return before going back there.
But hold on a second. You adding 1.
Yes. Look.
Okay. All right.
1 second. Let me. Once we get to 2 here, these 2, we are not just concatenating, but we are incrementing the index 2 to 3. And then here, it was 2, and then we incremented to 3. And when we get here, it is already 3, then return, and then it's over, right? That's why you don't get here on index 3. You get just here.
Yeah. I was thinking like inside the instead of index +1, I thought that you needed to be ++, but it's not, because every time that you go into the function, that number already is assigned to index. So you already.
Yes.
Okay.
Yes.
Got it.
Okay, so let's run the code. Output. Oh, this is not right. Input. This is output. What did we do? Partial.len. Okay, let me do this. If index is equal str.len. Yeah, we couldn't be partial because partial, it starts at 0 and this starts at 0. That's why we were having this here.
Already give you 0, right?
You just get here and by. But now, run code. Now we get it.
Nice.
Because str is the length of this index, the length of the original input. And it's not just this. The runtime is 100 milliseconds, and let's submit this. Runtime 88 milliseconds, faster than 77% of JavaScript online submissions.
How many tests does it runs? Do you have any more test cases in there, or just run 1? Okay.
63 test cases.
Okay, so you passed 3 cases. Wow.
Yes, passed everything. And there's a way of optimizing this to make it faster. Okay. But if we start talking about this today, we're gonna just finish this talking about this problem. But I'm gonna show you here. I have this solution here.
Okay.
And this is 97% faster than
wow, really?
all this.
Nice.
So let me show you here. I can explain pretty quick. So before this is still the same solution, but with different okay, so let's go back here. There's this one. Okay, this one. This is also 97%, but it takes memory to do that. Because here I'm pushing to an array.
Okay.
I push, I call, and then on the return, I do a pop.
Kind of like using concatenation. Okay.
Yes. No, I'm not using concatenation. I'm doing with an array. The difference is when we concatenate, we have a linear time. So that is O of n. We need to go through the entire string in order to concatenate at the end. But if we do a push to an array, this is O of 1. This is a constant time, right? We don't need to go through the length of the array. We just push it there. And then this is another constant time. We just pop out, and it's way faster than just, well, there's not even this on with the strings. But this is faster. And especially if it's a longer string, it will run way faster. But it's still the same two solutions. The time complexity is log of n. All right, so this is letter case. And I'm going to put this solution, letter case permutation. I'm going to put this solution here, letter case permutation. And subset. That's the last exercise. Let us delete this. Let me clear this also. Okay, so close this. Okay, so a subset. Do you guys know what is a subset, right? A subset is, if we have an array with 1, 2, 3, we need to return all the different unique elements. So unique is an empty array, number 1 by itself, number 2, 1, 2, 3, 1, 3, and 2, 3. This is all the different solutions that you can have when it's regarding to a subset. Okay, so it's given an array, given an integer array nums of unique elements, return all possible subsets, the power set. The solution set must not contain duplicate subsets. Return the solution in any order. So it's basically, let's get this as an example, okay? So let's get actually the result. And let's put here. Okay, this is our result, all right? And let us clear this. And we do have here 1, 2, and 3. Okay, so what's the base case here? The base case is going to be the same, right? The index, how many times that we call, we increment the index. But we are going to use a pattern here that is exclude and include, rather than lowercase and uppercase. Okay, so if we're going to start with an empty array. And then if to the left side we exclude, the right side we include. All right? So when we talk about exclude, so we are not going to add anything. We're going to have, this is index 0. And here we include
1, 2, 3.
No, we include 1.
Well,
we include 1.
I mean, okay. If we could exclude 1, 2, 3, and we have 0, then on the right side we will have all the 3, all 1, 2, 3 array completely. No.
Look at this.
All right.
This will blow your mind. So to the right side we include, to the left side we exclude, right? So next iteration, to the left side, we exclude, so it's empty. To the right side, we include, right? So, and if this was the iteration 1, I wanted to see at the end if it's 1 or 0. So we include 2 here. And on the left side here, to the left we exclude, so we keep 1. And to the right we include, so we'll have 1 and 2. Are you getting it already?
I'm getting there. Keep going.
Okay. To the left side, we exclude. So we continue here. We have an empty array. And to the right side, we include. What's the number that's going to come here? Right here.
I would think is 3.
Is 3, exactly. So if we exclude to the right side, here will be 2.
And then
And what's going to be here?
1.
No.
Empty? No, it's gotta be 1.
To the right side, we include
2 and 3.
2 and 3.
Okay.
Exactly.
Yeah.
2 and 3. And this is index 2. And here will be index 3. So, that's
Yeah, you're out of space, but don't worry. Keep going on the left side.
yeah. So here we exclude, we have 1. To the right, we include, we have 1, 2. So there's one, wait a second, it's not 1, 2. It's 1, 3 because we are in the 3rd iteration. Okay? 1 exclude, and then 1 we include 3. So here, if we exclude, we will have 1, 2, and to the right we will have, I'm gonna put here, 1, 2, and we include, so 3.
And that
So now we have empty array. We have 3 right here. We have 2 right here. Well, let me 2, 3 right here.
1
right here. 1, 3 right here. 1, 2 right here, and 1, 2, 3 right here. This is our solution. We got it. And this is also a 3, right? How do we code this?
to the 3. That's 8. No.
Let's
2 to the 3 is 8, right?
What was that?
2 to the power 3 is 8.
Yes. So look at this. 2 to the power 3 is, no, it's not. Well, it is the, yes, because here's 0, here's 2 to the power of 0, 2 to the power of 1. No. This is 2 to the power of 0, to the power of 1, to the power of 2, to the power of 3. Yes, you're right. This is this.
I mean, I'm just saying that's one way I was thinking about it, but I don't know.
Yeah, no, but you're right. 2 to the power of 0, 2 to the power of 1. No, this is not correct.
Because 2 to the power 0 is 1, multiplied by 2 to the power 1
Yes.
is multiplied. So it's
That's
1
here.
times 2 times 2,
2 to the, yeah, so
Or-
it will be 2 to the power of 1 and 2 to the power of 2.
But just keep going. Sorry.
Okay, yeah. So now we start solving this here. And we are going to use the same approach as the last one. In fact, let's do this. The only difference is this is not a string. This is an array. Index equal, and this is, well, we can use this, well, I'm going to change this to num just for the sake of num. Let's use nums, which is the same. Nums, index, partial, result, And this, okay, we don't need to use this. Don't need this. Don't need this. And we don't need this. But you see, this is a template. This is the same solution almost, right? The difference here is that we are going to do, like that other solution I showed you, we are going to do partial dot push. What we are going to push? We need to push this. But on the left, we're gonna exclude. Let's exclude on the left. So if here we exclude, we don't do anything. We remove this partial, remove this, and start becoming even simpler. Now we include. When we include, we need to do partial dot push. What we are going to push now?
Nums index.
Nums index. We're going to push nums index. Do we need to pop? We do need to pop. And that's because this is going to be recursive. And the 3 works like this. The 3 works like this. We're going to call exclude, and we come here. We're going to call exclude, we come here. We're going to call exclude, come here. Then we're going to go back, and we're going to come here, we're going to push. When we go back here, we need to pop to clean this. And then we don't need to pop here because we didn't add anything. This is through the exclude. When we come here, we push, and then we come here, we push nothing, we don't push. But once we go back, we still don't do anything here. But here, we come here, we push 3, and then we go back, we need to pop. And when we come here, we need to pop again. And this is how functions work, right? So it goes to a stack, it comes to a stack here. And then I call once, I call twice, I call 3 times, and I call, and then eventually the last one that I call, it will get back to here, that comes back. Let me change this color. It comes back, you need to pop, you need to send it, take it out, that result, and so on and so forth. It goes. I need to always clean what I push to that particular array, because otherwise, once I get here to push and I call again, that array will be with the different numbers. Does it make sense?
Yeah, I'm just still wrapping my head around it, but that's okay. I think I know that if you go back, you're already grabbing the same array, and then you need to pop the last element because otherwise you would duplicate.
Yes.
One of the conditions of the subset.
Is this gonna work? Let's try it. Oh, I need to change this. Okay, try it again. Why did this happen? Does anybody have any clue why did this happen? So look our output here. There's a bunch of empty arrays, right?
It's like
You
you
did
need
not increase
like
the
an
index, right?
auxiliary.
What was that?
Go ahead,
I said
Marcelo.
you did not increase the index.
I am increasing the index.
Oh, sorry, never mind.
Does anybody else has an idea? So are you guys familiar with the concept of primitive and reference type, right? Okay, so primitive type, let me clean this. Primitive type, he allocates a space in memory right here. And then you can copy that, like variable A equal 5, you can copy to another variable, and when you do variable A is equal B, or variable B is equal A, it creates another space in memory. As for arrays, they are reference type. So what it happens is like this. You create a space in memory, and then if we do this result.push partial, we are just referencing, we are referencing the same space in memory. So we need to create a copy of that array. Otherwise, we are going to have empty arrays like this. And we do that, we do that, if we need just to create a copy of this and send it, we can use concatenation actually. Dot concat partial. These would create their own space in memory. And now we would have our result. This is in different order, but it doesn't matter, right?
Yep.
And if we want to send, we can just sort that. Ouch. Oh.
No.
It just closed.
Really?
No, but I have it here. Here. So I can just sort it. And
now run it under.
Yeah, it will be the same thing. Yeah, it doesn't matter because here it says return the solution in any order.
Yeah. You just wanted to make sure that you understood what the output would look like. Okay.
Yes. And we are covering all that scenarios that we had before, that we did on the 3, right? So that's the only thing that matters. So let's run this. Submit. 76 milliseconds, 83% faster than.
Way to go.
Yes.
We call Brazilian power.
Right?
Taking over the Russians.
Right. Yeah, so this is okay, so this is subsets. I'm gonna put this on the repository. Let me just
period.
I think I didn't connect this.
Created a repo.
Yeah.
Can you share files over the platform?
A lit code.
Or if not, you can do it later. I mean.
No, it's already here.
Okay. I will chase you down to San Francisco.
Right. So I'm gonna post this on the channel here on Slack. I'm gonna put on
Awesome.
career growth, and you guys can go there, take a look, and if you have any questions, just send me a message, and let's see if we can have more workshops like this. Hey Edgar, are you still working with PHP?
Yeah, I'm still working with PHP, doing different projects right now. We actually went from Jackal to Hugo. I want to try React. I haven't done React in a while.
I see. Yeah, this is what I've been doing for the last year. So
No, but that's awesome. This is actually a very, very good. I didn't want to miss this for the world. First, because
yeah,
I haven't talked to you in a while, but
yeah,
also,
right.
yeah, also because this is a really good skill to learn, like creating algorithms. Like you can know this, you can learn the syntax, you can learn how to compile JavaScript code, and most of the things that you do when you're starting out is basically like sending a request and getting some data and just presenting the data. Here comes the grueling, really nitty-gritty of the fintech companies on how to do algorithms to manipulate that data and sort it out and spit it out. And that's very, very a good skill. Thank you for sharing. I really appreciate it. And the tools that you use, I keep track of those because definitely I have done like similar like testing on how to do an algorithm, and they do it, run a test, and they tell you the percentage how good your algorithm is. That's a really good skill to learn. So thank you for sharing that. We appreciate it.
Yeah, no problem. I've been solving those lead code exercises for a while now, and the fact is, there's some when we use the right algorithm, it's amazing. There was one of this week I solved one that was 100% faster than everybody else. And there
Wow.
was 190,000 submissions. So it's great when you just spend time doing this, and it makes your code way better. And some people say, well, when we are going to use this kind of code in your work, we don't use because because we don't know. Because once we get to know those kind code, we implement it for sure, and it runs faster.
Not only that, it's like maybe solving that type of problem you don't use in your current job, but it's critical thinking. It allows you to think like a computer,
Yes.
think on how to go step by step and trying. I'm so rusty in that. I was like, yeah, one thing is like a function or a method that does something, but how you gonna utilize that in the algorithm and see
Yes.
what person and later. And thank you for explaining about primitive and reference types. I don't know that, but
Yeah,
I
I do have, I can send you, I do have an article that I explain like in detail the difference of both and regarding to the code, right? And it's pretty straightforward. And actually, I already got stuck on this once, and I got like the whole day stuck. That's why I'm gonna write about this because this is so simple, and sometimes we get problem because of this.
so thank you for sharing. I really appreciate it. Wish you a lot of success. I see you're growing really, really fast. I'm trying to catch up.
Thank you very much. And really good talk to you, and thank you very much. I think this was awesome, like sharing this knowledge with everybody here. And I mean, we are in this development community, we need to share, right? And that's how we just move on and get better.
Awesome.
All right. So thank you very much, guys. Let's see if we can have another talk like this in the near future. And let me know if you have any questions about any of those exercises.
Awesome. Thanks, Joel.
No problem.
Thank you, guys. Thank you.
Thank you.
Bye-bye.
Thank you, man.
Good night,
Congrats.
everyone.